Hey there, Mr. Weaver here, and this is Topic 8, Lesson 1, Average Rate of Change, Part 1. After this lesson, you need to be able to interpret a given interval, and you need to be able to determine the average rate of change from a graphed function. You'll know you're successful after this lesson if you can identify the start and end of an interval given in either interval notation or as a compound inequality, and if you can calculate the slope between 2 points on the graph of a function. Average rate of change is just the change in the y value from the start to the end divided by the change in the x value from the start to the end, no matter what happens in between. So if your function looked like this, there's a lot of change happening. It's going up and down like a roller coaster. The average rate of change only cares about where you start and where you end. So we would find the slope from the beginning to the end, no matter what happened in between. So what is that slope? So to find that, you would figure out how many up or down did it go and then how many to the right. So in this graph, it went down a certain amount and then another amount to the right. And we would just divide those two. So we're just figuring out the slope from the beginning to the end. Let's look at a few examples of functions that are already graphed. So first one, calculate the average rate of change between bracket 1, 2 bracket. Those brackets indicate what's called interval notation. All it means is that tells you where to start and where to end. So here, that indicates that we would start at x equals 1 and end at x equals 2. So for average rate of change, I'm figuring out the slope starting at x equals 1 and ending at x equals 2. So on the graph, if I figure out where x equals 1 starts, I'm going to put a dot there. And then where is x equals 2? So I would follow that up, and it looks like it is about there. So x equals 1 is where I started, x equals 2 is where we ended. We're going to find the slope. So there's the line connecting those two. What is the slope of that line? I'm going to count how many up. I had to go up 12 and to the right only 1. So I would divide those two. Up 12, to the right 1. 12 divided by 1 is 12. So the average rate of change of this graph between 1 and 2 is 12. So again, we just figure out the slope between those 2 points. Now it's your turn. Pause the video. Calculate the average rate of change between 0 and 2. Let's check. You should have found the average rate of change is 4. Here's how we get that. You're starting at x equals 0 and ending at x equals 2. So my points, I didn't indicate the points on there, but those green lines would indicate how you would move from where x equals 0 to x equals 2. You would go up 8 to the right 2. 8 divided by 2 is 4. So the average rate of change here is 4. So 4 would be the slope between those 2 points that are at x equals 0 and at x equals 2. Let's look at another example. Calculate the average rate of change between -4 is less than or equal to x is less than or equal to 2. This time, we're given our interval as a compound inequality. All this is telling us is that we start at x equals -4 and we end at x equals 2. So we want to know between -4 and 2. So just like before, I'm going to plot my dots where x equals -4 and where x equals 2. And I'm going to figure out the slope of the line that connects those points. For this one, we had to go down 6. So it would be -6. And still to the right, 6. So plus 6. -6 divided by +6 is equal to -1. So the average rate of change for this one is -1. Now it's your turn again. Pause the video. What is the average rate of change for that given interval? Let's check. You should have got 14. Now, if you put 7, you didn't necessarily do anything wrong, except notice that it is counting up by 2s. So, we're starting at x equals 2, ending at x equals 3. So, counting up by 2s, it went up 7 squares. So if you got 7, that's what happened. And it went over 1. We can't see the scale on the bottom, so I'm going to assume that 1 square is equal to 1. If you said the answer was 7 because it went up 14 and over 2, you have a good argument. Here I'm going to say that it went up 14 and over 1. So my answer would be 14. Okay, again, you're just figuring out how much did it go up or down and dividing that by how many squares over. In this lesson, we learned about the average rate of change from graphs. So finding the average rate of change on a graph is just finding the slope between 2 points and then ignoring whatever happens in between. So as we saw in the very beginning, the graph could go up and down like a roller coaster, but for the average rate of change, you only care about where you start and where you end. We also saw there were 2 formats for the intervals. The first, you may see it written in interval notation where it gives you 2 numbers in brackets. So like 3 and 6 there are in brackets. If it's written this way, the first number tells you where to start, the second number tells you where to end. So we would start at x equals 3 and end at x equals 6. You may also see it written as a compound inequality, such as 3 is less than or equal to x, which is less than or equal to 6, where the left number tells you where to begin and the right number tells you where to end. You may see either of these. They both mean the same thing, telling you where to start and where to end. Finally, to calculate out the average rate of change, you're just dividing. So how much did the y value change? How many did it go up or down? Divide that by how many did it go left and right, which is your change in your x. Okay, I always go to the right. That way my bottom number is always positive, but that is just my preference. You can also figure out how much the x value is changing just by thinking about how long the interval is. So in our example of 3 and 6, if it started at 3 and ended at 6, the interval, the x value, would be 3, because from 3 to 6, it's 3 units. So you can also figure out what to divide by your x value by just figuring out how long the interval is. After this lesson, do you now know how to interpret an interval that's given either in interval notation or as a compound inequality? And do you know how to calculate the average rate of change between 2 points on a graph based on the interval that you are given? If you're not sure about these things, go back and look at some of the examples of what the intervals mean and how to find those points to calculate the slope between them. And that's the end of lesson 1 on average rate of change, part 1.